Do you have any log files or anything about where the crash occurs? Usually, if Unity crashes, there's a call stack or something else in a log file. Alright, so I think we're just going to change this to direction dot size squared is less than tiny float. Then we've arrived. This will be impos.y. Alright, so new position x is going to be, okay, so we can just do new position equals impos plus direction. So yeah, we can kind of get rid of some of this garbage town stuff here. So this will say new position equals impos. So we can just get rid of some of this code, and we don't have to do any of this stuff. You know, getting rid of code is what we need to do. Where's the cave today? Hello, Kento456. The cave is sleeping. The cave's gone away. We'll get back to the cave. I'm just writing out. I'm refactoring some of the particle code. You know, trying to get rid of some of this garbage that I got rolling around here. Got a lot of garbage rolling around here in the particle code because I got real sloppy yesterday at the end. What's he said about the hamster? I don't want to know. You called the hamster garbage and you let him roll around, Hurricane? I mean, if I had a pet hamster, I wouldn't call him garbage. That's just mean to hamsters. Why would you do that? Alright, we're just refactoring here, so we've broken a lot of stuff. Let's get some more compile. A funny lag conversation. Alright, looks like Adam's back online doing his material work and all that. Cool. It's nice to see, like it's consistent work inside of a system. Like you can just tell, just looking at him for like 2 seconds, that is like much more familiar with everything. So it's cool to see, everything actually coming together, starting to learn how to actually use all the stuff and all that. So it's good times. And I'm sorry, Liquid Predator, I can't help you if you don't give me a little bit of information. Sometimes, though, all you need to do to solve a problem is complain about it to somebody else. And if you successfully complain, it might just start working again anyway. Alright, so we need to set this start x and y, so pos.x equals particle.msx and particle.pos.y equals particle.msy. Alright, let's see. Key is not a member of f vector. Alright, so this will be for f vector. Let's see, pause in this thing in position history. We'll just do Yeah, it'll be dir plus equals impos minus pos. Alright, cool. And we're gonna get rid of this function stuff down here. I'm gonna just comment it out for a minute because we don't need. I might want to look at this stuff or whatever, but I think we're gonna just get rid of it. Cool. This is not an F vector, it's an F vector 2D. That's correct. That was the only error we had. Alright, well, let's run it and see what we get. You sent a bug report? Yeah, well, I don't know, are you... I guess when you encounter crashes and stuff like that, I guess... Oh, it really depends. There's a lot of stuff that it could be... But it can be very difficult to figure out. That's one of the reasons that I really like using Unreal, because I've got the source code, I'm running it inside of Visual Studio, so if I have a crash anywhere in code, I can see exactly what crashed and why. And I can't really do the same thing in Unity because you don't have all that source on you. You could try running, attach the debugger to Unity itself, which you can do with Visual Studio if you're. I think it's inside of the debug. There's like an attach to process and all that stuff. There's a really good Visual Studio plugin for Unity which I use. Well, have used, and that makes it real simple to do all that sort of stuff. You get some deadlocks and all that with using it, but it does actually work. Alright, so if we take our flow field. Alright, well, we don't have our crazy shenaniganry going on anymore. Alright, so let's change this tick real quick to tick 100 times. And we'll see if we get any odd behavior with lots of ticks on this thing. So what we would expect to see is these objects trying to move towards their destination. We shouldn't see any real thing other than that. And it's going to try to spawn particles, but it's not going to be able to. because things are in the way. So, stuff like that. Thank you for following, Liquid Predator. Sorry I can't really be of much more help to you. We used Unity a bit on... I haven't used the landscape system with Unity. Like, the games that I've made in Unity have been like 2D and all that, so I wasn't like putting a whole bunch of stuff together and all that. So if you had questions about, like, you know, the 2D animation system and crazy crap like that, I probably would know more than probably that other system. Alright, so this is good. What I want to do is I want to throw some random particles on this and make sure that they go towards this location over here. So I'm going to go ahead and shut this down and throw some random particles on there. So we're going to have spawn particles, and what I want to do is have like a number of particles. Let's see, is this something that I call? Yeah, okay. And should we have a set number of particles per frame? Yeah, let's basically just take the random particles per frame. Let's say it equals m width times, you know, like 0.1 or something. So if we have 512, we'll have 50 particles. I mean, maybe we should have, you know, something less, you know, like 25 particles. So let's see, we're going to try to add a particle every single frame here. Thank you for following Flecko Gold. We're just spawning some particles on our flow field so we can kind of get the direction that water will be traveling in a lake. And what I want to do here is I want to actually create like tri-spawn particle, and we want to give an X and a Y for that. So yeah, we're just going to make a new function for this. We're going to have void flow path map tri-spawn particle in 32x and 32y. And we're just kind of breaking this stuff up into better code than we had before. And the reason I'm doing this is because if I'm spawning particles in two places, I have to copy paste it, and I'm obviously going to make copy pasta error because I like to cook and make dinner, especially pasta, and it comes back to bite me. So we're trying to cut down on that carb intake. Alright, so random location, I think what we want to do is... Should we just make a random location entirely? Like, we might as well. So let's just grab our random number generator here. I've got my own math util functions for all this stuff. Try spawn particle, and they just kind of do what they want. We're pretty much in every project I've ever done, there's a lot of utility code that I put together. That kind of the first thing that I ever do with a new language and project is I put together a whole bunch of utilities that I can actually use for everything. So, like for serialization, like you're gonna want to change an object into JSON. You're gonna want to change it from XML into an object and back to string or whatever. You're gonna want to get, the command line stuff. You're gonna want to get like the system information such as processors and everything. You're going to want to get everything about time, and you're going to want to be able to spawn threads and thread jobs and make threads work. You're going to want to read and write from files. One of those is random math stuff, like just simple helpful things like remapping floats, interpolating everything. So it's kind of funny. If I'm like starting a huge new project or something, it's like, alright, it's going to take me like a month. I'm going to build my toolbox back up again. It's just porting a bunch of random code around. I've pretty much done that everywhere. Alright, so we need the destination X and destination Y on this thing. And it's interesting, I've been doing that basically since forever, so it's kind of funny. Some of the code that like I wrote back in college has been ported like maybe 7 times or something because it's just like I need the same thing. Alright, so this was path.m something. What was it? EX and EY? Alright. Alright, we have this flow field on here, so I guess we need the flow fields. Yeah. Alright, so we're going to grab a random flow field out of this. Actually, we're just going to do this a little bit differently. We are going to get a flow field of, it's going to be impaths, and we're going to do I mod flow field impaths.num. So we'll get the remainder of this, so it'll go from 0 to 1 minus the number itself. So that'll cycle through our paths. So if path.m found path equals false, we're going to continue. And that's also one of the things I like using early outs and continues and loops to keep those braces a little bit under control. Alright, so we need path.mex, path.mey, and flow field passed in there. So that should allow us to spawn a particle. Let's do it. Yeah, speaking of porting code, that reminds me of one time we were interviewing this guy. And, one of the things that you're not supposed to do as an engineer is steal all the code from your previous employer and take it with you. That's just kind of a no-no. Like, it's kind of illegal. I'd say it's probably more common for people to grab code and use it as references and things like that, and all that. But some people are just like don't give a damn. Like we interviewed one dude who literally like as his actual interview sample code just like submitted code from his previous job. And you might think like, okay, you know, like this guy obviously the overloaded function takes two arguments. Let's see, do we have getIndex? What the hell am I doing? So yeah, we and this was like how kind of our interview process had gone at that point was we'd have somebody on a phone call, and then if they passed the phone interview, they would come on site, and when they came on site, we asked them to submit sample code for us to look at, and like any information they wanted us to look at before they came on site. So this guy was already coming on site because he had passed his phone interview. So, you know, and usually what happened is before we're interviewing a guy, we'd sit down as like, you know, we do like pair interviews or whatever. You'd sit down as like a pair with the other guy and you'd go over the material that the guy submitted and talk about what questions you're gonna ask and all that. And so, you know, we like, and then you kind of walk in and meet the guy. So it's not like we read his sample code that he had submitted to us before we interviewed him face to face. But we looked at it and it was like the database code for a credit card company. Like this is the code where he's literally like this is the guts of some like commerce transaction stuff that you really don't want people to like. If he's stealing code from a commerce server, like Jesus Christ. And so we like, you know, like, we're looking at this code and just like you know, because it's got like the copyright of the company at the top and everything. You're just like, something's horribly wrong here. Alright, so we have all of our random points. And let's actually change our tick window here to something reasonable. Like, so we go into the interview after this, you know, to like talk to this guy. And we're like, so you submitted source code that like isn't yours? Um, you know, did you mean to do that? And like, you know, what's the deal? And this guy was like completely unapologetic. He was just like he did not give a damn. He was like, isn't this what everyone does? You know, like. And I know this looks real blurry, but I'm just watching these blurs and making sure that they all are moving in the correct direction, and it looks like they are. And yeah, we called up like the boss of the previous company and told him what was going on and all that. Pretty standard procedure. Alright, so this stuff is looking like it's working. And you can see the flow going on. Is not everything moving? Like I only see certain things actually moving. Like I would expect to see like some of these pixels actually moving properly, but they don't appear to be. It seems like our pixels are getting stuck. I would be very much expecting these other pixels to be spawning in here. Like we're not seeing anything come in here and move. I mean, we're seeing them move, but like nothing's moving in these big patches. It's like these pixels are getting stuck and then they can't move anymore. You know, like we'd expect this area to move down, so. But it's just not happening. Alright, well, let's see, why would that be? Well, let's see. It might be that we have some issues with our removing of nodes and stuff like that. I've got like a linked list of particles going on. It may be that the linked list of particles is just trash, and I'm just going to turn it into a T-array. And it'll be less efficient for stuff, but yeah. I'm not convinced that... I'm not really too familiar with how the linked list stuff works with Unreal, and it wasn't really working kind of how I would expect their linked list to work. And particles sub I dot tick star this flow field, because I'm thinking like one of the reasons why those things aren't moving is maybe there was like some sort of linked list got screwed up and they're not even getting ticked anymore, which can definitely happen. Also, this removed node here is not actually clearing the collision map, is it? Alright, so we'll just remove that. Also, we need to clear the collision map. So, M particles sub I M pause. So let's see, the set collision at this position to false. Alright, cool. So we'll go ahead and delete that. Yeah, there's all sorts of crazy interview stories. I mean, that's just what happens. Like, it's just funny when you do a bunch of interviews with people. Just there are crazy people out there. They exist, and there's a lot of them. People make interesting decisions. I think my favorite interview stuff was when people would submit like 10-page resumes for stuff. Because like I'd be looking at a resume, and if it's like 10 pages, I'm like, Jesus Christ, like either this person thinks every little thing is completely relevant, or what. Like when I was doing like interview stuff for companies, it was one page is all you need. Just if is there any relevant experience to the actual job? Like what we posted. That's all we care about. We're just looking like C++, or Java, or web servers, or game industry experience. And if you have a college degree, that's pretty much. And if it was actually a comp sci, and that's it. And that's really all it took. Like you could have a 4-line resume that just says like, I actually know what's, I actually have qualifications that pertain to this job, and just list exactly the job description and say yes, I have those. And it's boom. That's all we would care about. That would get you a phone interview. Having like 10 pages and like putting, like, oh, I know how to use Microsoft Word. It's like I really don't care. So we're gonna keep pumping this tick method and see if any of these things get stuck again. We've done that, but alas, never successful. So it is all blurry, and that's the texture streaming stuff, but that's fine. It's supposed to be blurry. Alright, so it looks like we're not able to move diagonally. Something like that. Not seeing any diagonal movement going on. So obviously, we have it's. I'm not seeing stuff getting horribly stuck. It's the diagonal movement. All right. So let's take a look. The only bones resume. Yeah, one of the things that's always hilarious is people would like put assembly on their resume, like, oh, I know x86 assembly, and because I took like one class on it in college or something, and then and the funny thing is like then some dude in the interview would like ask you about it or something, and you'd be like, ah, Jesus Christ. Because there's always somebody who's like real interested in that and thinks they're super smart and wants to show how smart they are. Okay, so what's going on here is we're checking if the space is occupied, and we're actually finding that we are occupying our own grid square. So what we want to do is we want to check if our current position, like um, if we're in a new grid square. So we want to check Alright, so we're going to say if, let's see, it's going to be new position.x, so it'll be fmath floor to int equals, fmath floor to int impos.x. And the same is true for the y value. Then we're in the same spot after our move. And what we're going to say is moved equals false, and impos equals new position. And we'll just do an else if here. So we're not going to move, but we're going to increment our position. So we will actually record everything properly, but we're not going to screw anything up there. And that might be what was going on with our linked list. I'll probably return the linked list thing there because it's more efficient for probably what we're dealing with. Because if we're deleting particles in the middle of a vector, how vectors work is they're just a continuous chunk of memory in one location. So if you try to remove something from the middle of that chunk, it has to shift everything over that's after it. So imagine if you have a line of people and you take one person, you're like, hey, Joe, 100th dude in line, can you step forward? And then everybody there, if there's a million people in this line, they all have to move one square down. And as you can imagine, if you got a bunch of fat people in that line, that might be a big problem, right? You might have to get some wheelbarrows out there and people to help, and that would be a real pain in the ass. So a linked list basically is a different data structure where you point to the next element. And so instead of having the two people next to each other have to fill the gap, everybody shift over, it's just the guy who is there just points to the guy next in line. And no people have to move. You don't have to get the wheelbarrows out, and it works real well. Of course, it's less efficient. So let's see, are these things actually moving? It looks like they're moving in there. So we're gonna find out here is this is going to not be that plus shaped thing. It's gonna start becoming a ball. So yeah, that appears to be working. So everything is moving around properly now. And the reason I'm kind of messing with this is because I wasn't getting the movement I was expecting out of these particles before. Things doing weird crap. So alright, so I want to fix one issue I've got here, which is why do I have a gap in these lines? If we're spawning these particles, why do we have a gap in the line? So what do we do for particles? What's our... We call move particles, then we call spawn particles. So all the particles should show up just immediately. And I think we need this space occupied thing Yeah, we want this ignore flow field in here. Yeah, and we want that on these guys. So let's throw that in there. Let's also swap our particles back to that link list. Yeah, and I don't think I'm going to be doing a 14-hour stream today. I'm just going to throw that out there. But everybody should peer pressure Adam into doing something like that for having missed 2 weeks. No, actually, don't do that. Leave him alone. He needs his rest. He's been busy. He needs to chill out. A 14-hour ripoff. Yeah, how dare I do something other than stream on Twitch? What a horrible person. Like leaving the basement. That was pretty funny going over to Seattle on Friday and hanging out with some people for a dinner, going away dinner for a friend. And talking to people, and there's some like fellow people who went to the same college I did and stuff like that. All right, so we swapped out our algorithm. So yes, we have a continuous line here, and we swapped to our linked list. Let's make sure our linked list is actually doing what it is. And it was just that XY stuff. It looks like it is. So one of the things we're going to have problems here are with particles that are in the same spot, because we are spawning particles. We are not spawning particles in the same spot. It just ignores the flow field. All right, so we're doing all right. All right, so I think what we need to do now is actually start doing our directionality. Yeah, going over to Seattle, hanging out with people who went to the same college, and they're like, "Oh, what do you do?" And I'm like, "Well, I've been an independent developer for a year, and I pretty much sit in a basement and I talk to people online, and I type on my computer, and that's pretty much my existence." And they're like, "Oh man, that's so cool," I wish I could do that, but I have like responsibilities, and you're just kind of sitting there, and you're like, you know what? You're describing basically like the biggest loser job on the planet, right? You're just like, what do you do? It's like, I'm a basement dweller, like I don't go outside, I don't see anybody, and they're just like, oh man, you're so lucky. It's like, this is stuff that like people back in the day, right? Ancient times, they would just like barricade themselves into caves, and people would just like bring them food and be like, oh man, that guy's like super wise. And he's just a mystic in there. He's like, what the hell do you do in your cave all day? He's like, nothing. Go away. It's like, oh man, that guy's so smart. I want to be like him when I grow up. Alright, so we need to actually get our particles to start moving properly and doing what they're actually supposed to do. So how in the hell are we going to do that? The wise old hermit. Yes, it is true. So we have our positions, we have the directions that we want to go. So, Gotta keep up appearances, it's true. So I'm trying to think of exactly how I want to do some of this. So one of the things we want to do is we want the water to kind of avoid the other water particles. So we can like look around ourselves, see if any of these areas are marked as having collision. We can then like weight a vector based on that in the distance, and we'll get like a vector away from stuff, and we can add that in there. We also want to have like a speed for our water. We want like a velocity for a particle, and what we could do is kind of we could have momentum built in here for the particle, so that the particle has like a velocity that we add to every frame, and that velocity like peaks at something, and we kind of move it around so the velocity, you know, tries to go towards the thing but also weights itself away from everything else. So what we do, we add some, you know, f vector 2D in velocity, and let's have like an int32 max velocity, or like float in max velocity. So let's go ahead and make that. So when we create our particle, particle.m max velocity equals, let's give it a maximum velocity of like 3 pixels per tick. Let's also have like a float in depth radius and an int32 a void radius. So the depth radius is going to be the radius around the position that we're trying to get to, where the particle should kill itself. I'm going to set that to like 5. And the m of void radius, we're going to set that to like 5. So every particle is going to check 5 pixels around itself, basically in a square, and try to avoid particles in that. So let's see. So what we're going to do is we're going to want a kind of a wanted direction. We also want, like, for our object, we want like an m acceleration. So like how much per tick it can add to its velocity. Let's say every tick can add, you know, like 0.5 to its velocity. So we're going to say this will be our wanted direction. So our wanted direction. So we're going to say we want to weight our direction towards our destination. So wanted direction plus equals this is going to be an f vector 2D. Alright, so we want to do like for int32, yeah, we're going to want like int32, we want the number of objects that we have. So int32 I equals 0, I is less than m of void radius plus I. So it's going to be this like x and y value search. So for int32 y equals 0, y is less than m of void radius plus y. And for our void radius, let's just be super dumb about how it works. Let's basically just say the avoid radius is an actual radius. So what we're going to say is basically x equals negative m avoid radius. X is less than or equal to avoid radius. So it's going to go from -3 to +3 in this case. And if x equals 0 and y equals 0, then we're going to continue. So what we're going to do is we're going to say, like, is space occupied for this position, and we're going to say, yeah, f vector 2D test pos equals mpos, and then test pos.x plus equals x, test pos.y plus equals y. So have our test position right there. So if the space is occupied, then what we're going to do is we're going to increment the number, so that's the number of things, number of vectors in here. So let's say this f vector, a void vector, I'll initialize that to 0. Alright, so the avoid vector is going to, we're going to add to the x. This will be what, -x, and avoid vector dot y plus equals -y. I'm just trying to think about what number I want here for this, because we probably want the avoidance radius to fall off, but we don't necessarily have to. We can just basically add in the direction. So like, we do an f vector 2D, it'd basically be the, dir would basically be equal test pos, be the direction should be mpos minus test pos, and then we would normalize this, and then we would have our avoid vector plus equal this value, plus equal the normalized direction. So everything has equal weight within the radius. Which isn't really what we want. Anyway, so what exactly do we want to do with this avoidance? How strong do we want the avoidance vector to be? Compared to our wanted direction. I guess we can kind of play with that number and see exactly what we want with it. We want it to be pretty light, so let's say wanted direction equals, let's just be explicit. So f vector 2D direction to goal So the wanted direction is going to be the avoid vector multiplied by this float. We're going to have avoid weight. Yeah, so we want to, if num equals 0 is greater than 0, we want avoid vector divide equal by num. So the avoid weight, we're going to say that's 1.0f. So we want to add the avoid vector plus the direction to goal. Let's normalize this thing. So we'll add these two vectors together. Avoid vector times avoid weight plus direction to goal times goal weight. I'm going to make these variables here real quick so I can just easily mess with them. And then we'll just do wanted direction dot normalize. Alright, so and we'll want our kill switch here, so we want to get the direction to goal here, so I'll have distance to goal equals direction to goal dot size. So if distance to goal is less than m def radius, return false. Let me get rid of this. Alright, so we figured out where we're supposed to be going, which direction we want to be. So we want to take our current velocity, so m velocity plus equals m acceleration times wanted direction. And if m velocity dot what? It's going to be the size squared is greater than the m max velocity, then what we're going to do is m velocity equals m velocity dot normalize. Yeah, all right. So it's just going to be m velocity dot normalize, and then m velocity times equals m max velocity. So we have the issue here where if our speed is too high, we'd actually fly over an object that we want to die on. Alright, so we have our velocity, so the new position is going to be the position plus m velocity. And that should be good enough to work. So let's see how this works.